Hello and welcome to this live event and webinar broadcasted from sunny Sweden. My name is Magnus Rieger, and today we are going to discuss a topic, actually how to make tailing dams redundant. Together with me today we have our Industry Manager for Mining, Mr. Amol Shinshankar, who will guide you through this very interesting presentation. And don't forget to write your questions in the queue or in the chat, and we will try to answer them as good as possible in the Q&A session after the presentation. So now I give Amol the lead. Over to you, Amol.
Thank you, Magnus, and hello, everybody. Today we will see what the soluble centrifuge technology is about and how Alfa Laval is helping our mining customers to achieve their safety and sustainability goals. So the title of my presentation is Solid Bowl Centrifuge Makes Tailings Dam Redundant, and this is based on a true case story in Australia. So here's the agenda for the presentation. We will start by looking into the background of let's say a solid bowl centrifuge technology, and then we will see where it stands today. How far it has evolved. Then we will talk about Alfa Laval's product and technology vis-a-vis the solid bowl centrifuge. And we will also look into a couple of customer cases. The first being Rix's Creek in Australia, and another large customer who is into oil sands operations in Canada. And then we will, of course, go through the benefits of using solid bowl centrifuge for mine tailings dewatering. And we will wrap up the webinar with a question and answer session. So let's get started. Now, talking about the background of the solid bowl centrifuge technology, it has been around for the past more than 60 years. However, it has made inroads into the mining industry pretty recently, say in the last 10 years or so. And there are a couple of reasons behind that. The main reason being the old design of the centrifuge had limitation on solids handling capacity. And as you know, mining operations are huge and they need very big, very large dewatering capacities. So the old centrifuges weren't up to the task. And the second important reason was that they were not equipped with the best quality of wear protection. Mine tailings duties are very tough, and they contain a lot of erosive solids. So today's centrifuge is well designed to handle that. And then if you look at the geometry of the bowl and the conveyor design in the past, those were not very optimized for tailings dewatering operations. So that's how the old design was. And talking about today's design, in the last 10 to 12 years, Alfa Laval has invested a lot of effort in developing the right kind of solid bowl centrifuge for mine tailings dewatering. Today we have the highest capacity centrifuge in terms of solids handling, and we have also developed the best or most robust parts for handling erosive duties, especially such as mining tailings. Now these features have made our solid bowl centrifuge more suitable for the mining industry than ever. And that's how Alfa Laval has started a new era in tailings management. So this slide shows a picture of our solid bowl centrifuge. And I will take you to the next slide, where it shows a cutaway section of the centrifuge. So here it is. And allow me to explain the different parts of the centrifuge. So you can see the solid bowl, which is made out of stainless steel or duplex steel at the center in red periphery. So it's a ball, which is a ball shell, which is made out of solid stainless steel, and the shell thickness is something like 13 to 15 millimeters. So it's very strong, and it is centrifugally casted. It is cylindrical in shape, and there's a conical shape towards one end, which is the right side, as you can see in this picture. And inside the ball, there's a screw conveyor. It's a helical screw. Both the ball and the screw conveyor rotate in the same direction. And these are rotated with the help of the two motors that you can see. On the right side is the main motor, which is bigger, and it drives the ball. And on the left side, on the frame, you can see a small motor which is connected to the screw conveyor located inside. And the rotating assembly, the ball, the conveyor, as well as the gearbox that you see, which is in orange color, between the back motor and the rotating assembly. This whole assembly sits on a very sturdy frame. This frame is made out of mild steel box spring profiles, and this frame has 4 legs, and under each leg there's an anti-vibration pad. Because all said and done, this is a high-speed equipment, and it does generate a little bit of vibrations. So we take care of that by putting those anti-vibration pads in place. So this is how the equipment looks. It's very simple to operate. And let me now show you an animation, which will give you an idea as to how it functions. So here's the animation. You can see the feed tube in white color on the right side, and we have removed the casing to show the ball. Now the ball has been cut to show the screw conveyor, which is inside. And through the feed tube, the feed enters into the centrifuge. The conveyor shaft is hollow, allowing the feed tube to enter through it. And the slurry then enters into the centrifuge through openings that are there in the conveyor shaft. So we call those as windows. And as soon as the slurry enters into the, let me play this again. As soon as the slurry enters into the bowl, by virtue of the high centrifugal force, the solids are literally thrown against the inner surface of the bowl wall, where they get deposited, and then the screw conveyor conveys or pushes the solids outside from the conical end, as you can see here. These are the solids coming out from the conical end discharge or solids discharge, and they typically come out in the form of a solids cake. And the separated water, the clear water, flows from the opposite side and can be collected in a tank below. So this is how the solid bowl centrifuge technology works. And we will be happy to, give you much more information when we get an opportunity for further interaction. So this is how the centrifuge works. And now talking about the product and technology that Alfa Laval has developed for its solid bowl centrifuges. As I mentioned, we have developed very large centrifuges which have higher capacity. So the largest machine that we have can handle 200 to 250 meter cube of tailings slurry per hour, which translates into 65 to 75 dry tons of solids per unit. So that's a pretty high capacity. And that's why now the centrifuge technology is appealing to the mining industry. Then Alfa Laval uses deep pond design and higher G-force. So our centrifuges have typically a higher speed of rotation, which we have been able to achieve through relentless R&D efforts. And the deep pond technology also helps in handling higher solids throughput, as well as making the solids more drier by using the hydraulic force from the liquid to squeeze out the solids. Then we have used or developed very ultra high erosion protection, especially for the mining duties, such as coal tailings, gold tailings, iron ore tailings, and various types of tailing duties. Suitable This technology is now suitable for tailings with high content of clay. In fact, that is a niche area for us because, as you probably know, many of the filtration technologies are not very much suitable for handling tailings with high clay content, but our centrifuge delivers very good results even on fine clay particles. And by now, we have quite a few operating references on mine tailings globally, including Australia, Canada, USA. We have made a breakthrough in Russia as well, in South Africa. So our technology is now working across many mining companies in the world, and quite successfully. And one more advantage of our centrifuge technology as compared to the other centrifuges is low power consumption. And this has been made possible by using a patented liquid discharge design. So this is how Alfa Laval has improved its centrifuge offering. And the centrifuge is controlled using state-of-the-art control system. As you can see on this slide, there are a number of different sensors, such as temperature sensor, vibration sensor. It has speed sensors. There's a load cell, and all this instrumentation is connected through a junction box to a PLC and VFD panel, and it's also equipped with a large 15-inch touchscreen display, which is very user-friendly, and therefore the operators find it very easy to use. So this automation helps in having a good control of the equipment and making sure that the performance in terms of solids dewatering as well as the centrate clarity gets optimized on a continuous basis. And apart from that, the automation also helps in keeping the equipment safe. For example, if the main bearing temperature sensor senses that the temperature has crossed a certain set point, the system will give an alarm. And if it then crosses another higher set point, the system will trip the machine. So thereby, it does not allow the machine to operate if it senses that something is not right, and therefore it damages it prevents the equipment from any damage. The same goes with the vibration sensors and so on. Now, this slide talks about the different dewatering technologies and what they can do. So there are, as you know, gravity-based technologies such as different types of thickness. You have high rate thickness, high density thickness, paste thickness, etc. There is a wide range of filter technologies such as bed press filter, the plate and frame filter press, and many others. And then you have the old solid bowl centrifuge technology, as well as the new solid bowl technology that Alfa Laval is now propagating. So looking at this slide, we can see that the sweet spot when it comes to gravity-based settling is particles as small as, say, 50 micron in size. So the thickness work efficiently at that particle size. I'm not saying that they don't handle smaller particles, but we are just talking about the sweet spot here. And then when it comes to filter technologies, the sweet spot for filtration would be around 20 micron particle size. For the old solid bowl centrifuge, they could handle smaller particles up to a few micron in size, but the new solid bowl centrifuge developed by Alfa Laval can handle solid particles as fine as 1 micron in size. So that's how the technology has evolved, and with the capacity to handle higher tonnages, the new solid bowl centrifuge is definitely one of the way forward when it comes to handling mine tailings. So let me now tell you the stories about Rix's Creek first, and then we will look into the Canada installation. This customer in Australia is a coal mine called Rix's Creek, and some years ago their tailings dam neared completion, and that's when they started evaluating different mechanical dewatering technologies. And in 2013-14, they, after evaluating different technologies, they selected Alfa Laval solid bowl centrifuge, and they commissioned the first unit, which was a 720 millimeter bowl dia solid bowl centrifuge. In 2015, they added 2 more units of 720 and in 2000 until 2017 they were sending a portion of their tailings to the existing tailings dam, but in around that time their local government advised the customer that they should not send any of the tailings to the tailings dam. They should stop using the tailings dam completely, and that's when they again evaluated and selected Alfa Laval's biggest solid bowl centrifuges, which is the 1,000 millimeter bowl dia machine, and those were supplied towards the end of 2018 and commissioned and handed over within a few weeks' time. And since those two large units have come into operation, Rix's Creek have stopped sending their wet tailings to the tailings dam. So since 2019, the tailings dam has been made redundant at Rix's Creek. So this is the performance of the big decanters, big centrifuges there, 150 to 210 meter cubes an hour, which translates to around 65 to 74 tons per hour of dry solids loading. The cake moisture on an average is around 65 weight%. And you can see it handles pretty fine solids. The average solid size or D50 is 20 micron, and it produces a dry cake which is suitable for co-disposal along with coarse rejects. So the picture on the right hand corner shows the cake, solids cake coming off our centrifuges on the belt conveyor. And this is the installation in Canada. We are proud to say that this is our largest installation in the world. We have 18 of our largest solid bowl centrifuges operating there, and they together dewater 30,000 dry tons of tailings every day. This installation was started in 2010-11 when they did the test with our first centrifuge, and then in 2012-13 they added 9 units, and then after a couple of more years they added some more units. So today we have total 18 units working on fluid fine tailings, which contains a lot of fine clay material as well as bitumen, sand, water. So it's a very difficult to dewater tailings. I mean, especially on account of the bitumen, which can be quite sticky. The feed rate to each machine is around 240 tons per hour. So the solids loading is around 70 to 72 tons per hour. And there are very fine particles. You can see the D50 is 10 micron, and it delivers solids cake with 55 weight%. Or 55% dryness, and that is good enough for the customer. They are happy with it. They are using it in land reclamation. By using the cake coming out of the centrifuges, they have turned some of their mining area into a virtual forest. And the water separated from the centrifuge is recycled back into operation. So let's have a quick look at the benefits of solid bowl centrifuge. It eliminates risk by avoiding ponded storage of tailings. That's very important with all the tailings dam failures happening across the world. The solid bowl centrifuge facilitates dry tailing storage by co-disposal or stacking or land reclamation. It gives a high throughput and continuous separation. So, and it demands very less operator intervention, thereby making it quite attractive to the mining companies. It saves water because it requires very less wash water as compared to other technologies for washing, and it also processes and recovers a lot of processed water. And while doing so, the life cycle cost is also quite attractive. It has a less capex owing to a smaller footprint. It requires less maintenance, and the polymer usage is also optimum. So with this, the mining industry is able to achieve its sustainability targets by avoiding tailings dam, by recovering a lot of water, and sometimes also by recovering valuable minerals from legacy tailings. So this is how Alfa Laval helps the mining industry to achieve their sustainability goals. So let's say no more tailings dam and yes to safety first, because this avoids using tailings dam, as you saw from the case story at Rix's Creek. And in doing so, we help the customers to recover more water, to reduce the quantity of waste generated, and our centrifuges also consume less energy as compared to some other designs. And overall, Alfa Laval helps our mining industry customers to meet their UN sustainability goals. We have shown only 3 goals here, but we contribute to many more UN sustainability goals. And talking about our ambition going forward, Alfa Laval would like to be #1 in robustness by having 2 years non-stop operation in all applications. We would like to be #1 in process performance, not only in existing applications, but also in new applications. And we would like to have the first autonomous decanter, which is self-diagnosing and self-optimizing. So this is all possible with the commitment that Alfa Laval has towards R&D. I'm happy to inform you that the company holds more than 3,700 patents in its chosen areas of market leadership, such as solid liquid separation, heat exchange, and flow technologies. So with that, I bring my presentation to an end, and I'll be happy to take any questions. Hello. Over to you, Magnus.
Sorry, yes, I was on mute. Sorry for that. Very nice presentation. Thank you for that, Amol. We have a question that came in through the registration, talking about the water recycling part. I mean, it's very important these days, and especially a lot of mining sites are in areas where water is very, very scarce.
Yes.
And the question is that can you recycling the water directly, or do you need in the many cases do you need to go through some other processes, or is it fine enough to put into the mining process directly?
Yeah, that's a good question, and especially with so much of water scarcity in different mining regions in the world. Well, the centrate quality coming out of the solid bowl centrifuge is good enough that it can be recycled directly. So it's not necessary to push it to process it through another, say, polishing centrifuge, etc. But of course, that also demands on the quality or the clarity of the water that is needed for a particular process. But in general, for mining operations, the water from the solid bowl centrifuge can be recycled directly.
Okay, thank you for that. Next question is, I mean, a lot of times those mines are could be in remote areas. Are there any possibility for kind of remote monitoring, or so you can actually plan your service?
Yes, most certainly. And we have developed the connectivity solution that uses a field gateway in our control system, and which helps in transmitting data from our centrifuges to us or to the customer, even on their cell phones, so they can monitor the operation of the centrifuge almost 24/7. And if they give us access, we can also help them in doing so. And this is pretty helpful if we have to give remote support to the customers, and definitely so in these times of COVID-19, where it's not possible to travel to remote customer sites. So a lot of our centrifuges are now equipped with the connectivity solution, and our field service engineers have been helping our customers to commission their equipment sitting at their home or their office. So it's a very useful technology, and it's available now. Alfa Laval has already rolled it out last year, and more and more customers are now seeing the benefit of being connected 24/7.
Thank you for that, Amol. Last question I'm having is that regarding the autonomous function, very interesting. Do you see this autonomous is what kind of benefits do you get? Will it be more expensive, and when can we get it?
Yeah, I mean, of course, I mean, it will. I mean, since it will be a newly developed technology, definitely it comes with its cost of development, etc. So to that extent, it will be slightly more expensive than the current or existing solution. But the benefits that can be accrued by using self-autonomous technology far outweigh the incremental cost. And we have already started in that direction. We today have centrifuges which with state-of-the-art control system, as we saw in one of the slides, and there we are able to stop the centrifuge operation if, for example, there's an increase in the bearing temperature or vibration levels, etc. But we would like to go one step further and try to diagnose a situation where, for example, there is some unbalance in the machine. And today we cannot find out unless it is dismantled and inspected. So our R&D is working hard to develop some technology which will enable us to diagnose this type of things with the aim of keeping the centrifuges up and running and giving maximum productivity to our customers.
Thank you for that answer, Amol, and I think that was the last question. So by that, I thank you all for listening into the presentation, and also for your information, we will post the recording on the registration page as well as on alfalaval.com under mining tailings. So you will be able to show or to listen into this webinar again. And by that, I say thank you to Amol, and I thank you all for listening in and have a wonderful day. Thank you very much.